Hello everyone! In this tutorial you'll learn how to create a basic Unity project using Nuitrack. In 2 words, Nuitrack is a middleware for full-body skeleton tracking, which also offers such features as face tracking, gesture recognition and more. As a result, you'll get a simple app with an option of skeleton detection and tracking. First of all, set up the environment for your project. Create a new project and name it, for example, Basic Nuitrack Project. Click Create. Then select the desired target platform, for example Android. Go to File, Build Settings. Select Android and click Switch Platform. Though we talk about Android, you can select any other platform for working with Nuitrack, for example Linux or Windows. Then download and install SDK and JDK if needed. To do this, select Edit Preferences, External Tools, and click Download in the relevant sections. Then your browser will open the websites where you can download the required SDK and JDK. And now here is the most interesting part that will add skeleton detection and tracking to our project. Import Nuitrack SDK Unity package to your project. Select Assets, Import Package Custom Package, and select Nuitrack SDK Unity package. I want to import the tutorials folder because it includes ready-made projects with Nuitrack, so we don't need it for now. Okay, and click Import. Alright, now that we've set up the environment, we have to set up the build. First of all, save the empty scene. Go to File and click Save Scenes. Then add the scene to the project. Go to File, Build Settings, and click Add Open Scenes. Don't forget to set your company name and product name in the relevant fields. Go to File, Build Settings, Player Settings, and enter your company name and product name. In the Identification section, select a name for the build, as you won't be able to build a project with a default name. For example, let's name it com.3dv.nuitrack. Also select API level 19 as minimum, so that Nuitrack works correctly. You can reduce the size of a final APK file by selecting ARM7 type of architecture in the Device Filter section. Now that everything is set up, let's build the project. Go to File, Build Settings, and click Build. So the build was successful and we can see a new window with our APK file. After the first build, when you have a ready-made APK file, you can build and install the project on your device by clicking Ctrl+B. To do this, activate developer mode in the settings of your mobile device and connect it to the computer via USB. Then press Ctrl+B in Unity. As a result, the project will be built, installed and launched on your device. Alright, now that everything is set up, we are ready to initialize Nuitrack and check skeleton detection. First, drag and drop the Nuitrack scripts prefab to the scene. There must be only one object in the scene. This prefab contains the scripts that interact with Nuitrack. Then set up the characteristics of this prefab. Make sure that Skeleton Tracker module on is ticked. This very module takes care of detection and tracking of a user's skeleton. As you can see, there are several more modules in this field. We'll cover them in the following tutorials. And now it's time to do some coding. Create a new C# script and name it, for example, native avatar. To get information about skeleton joints, we need to detect the user first. Create a new variable message that will store skeleton found and skeleton not found messages. In update, we use the if-else condition to check the user's presence in the frame. And we should also create the onGUI method to display the message and specify some text features like color and size. Don't forget to save changes in the script. Create an empty object and drag and drop the script to this object. Now build the project. And now we're ready to check skeleton detection by Nuitrack. As you can see, skeleton found message is displayed when the user is detected. Now it's time to move on to more complex things. Let's create objects to visualize joints over our skeleton. Let's determine the joints of the skeleton which we need to get. Declare the Nuitrack joint type and game object arrays. In the app, the joint will be rendered in the form of the prefab joint that we selected. In Unity, specify the joint type that you need in the object characteristics. So, Nuitrack detects up to 19 joints at the moment, so we set up 19 and select the joints. Please note that fingertip and feet joints are not tracked at the moment. Right? Then drag and drop the prefab that will be used for displaying the user's joints, for example, a white sphere, to the prefab joints field. To do this, we need to create a new object, for example, a 3D sphere, and scale it down. Then we need to create a prefab. And drag and drop the created sphere to the prefab. Alright, let's get back to the coding and let's create object to visualize the joints using the saved prefab. In start, create an array of the same size as the type joint array. After this, we begin to create their copies on the scene in the loop using the instantiate function. Now we define copies of the objects as children of the object containing the script. As a result, the position of the parent object will correspond to the position of the sensor. Now build the project. And check the user's presence. Now the spheres are located in the position of the native avatar object. Since they are yet located at one point, they look like a single sphere. Now let's move on to the final part and scale the joints. Now we have to match position of spheres with the position of the joints of a real user skeleton. In update, get skeleton information using current user tracker current skeleton and then process the joints info in the loop. To receive data on the required joint, call the getJoint function from the obtained skeleton, specifying the type joint. Let's calculate the joint position by calling the toVector3 function from the current joint. Keep in mind that 1 unity unit is about 1 meter, so we have to convert the obtained data from meters to millimeters. Set the calculated position new position to the created joint object. Alright, now build the project. To make sure that the user is detected correctly, set the Unity camera at a distance of 2 or 3 meters from our object native avatar. And make sure the camera is facing the object. Also, don't forget to delete the sphere from the scene. Now we are down to the final stage. We can check project, and if everything is done correctly, the skeleton will be detected, tracked and displayed. Nice work! Now you know how to create a Unity project with Nuitrack. From now on you can develop plenty of apps with skeleton tracking. That's all for now. Though this is a very simple example, it covers a large set of basic subjects, which can help you to understand how to use Unity with Nuitrack. In the next tutorials you learn how to create more complex and functional Unity apps with Nuitrack skeleton tracking. Cheers!